Friends, welcome to part 1 of our video presentation on Chapter 8. Chapter 8 talks about some of the most basic or fundamental systems concepts and tools. I would say that in many ways this is the most important chapter of the entire sequence. Now, the reason for that is that this chapter communicates the philosophical and theoretical foundation of the field of MIS, Management Information Systems. And there are like a lot of labels that are used in conjunction to this field of MIS, and some people disagree as to what exact meaning those labels have and whether they're synonyms for MIS or not. But I would say that roughly speaking, this chapter creates a foundation or communicates the foundation of such fields as MIS, Management Information Systems, CIS, Computer Information Systems, and also IT management. So I think those are the most common terms that are used to describe that field of endeavor that is somewhere in between computer science and general management. More specifically, in this chapter, we'll talk about the so-called systems view, and I would say that systems view is the most important aspect of the field of MIS or IT management. And just like the term MIS, the systems view has many synonyms in my opinion. One of them is systems thinking, and the other common one is soft system methodology. But here we'll stick to this definition, to this terminology, and we'll call it the systems view. Then we will also talk about, in other parts, we'll talk about business processes, how information systems impact business processes. Then we will talk about systems development life cycle and some structured techniques for that. Some techniques related to, or methodologies related to project management and managing the information system life cycle activities. And then we'll also talk a little bit about information systems control. But in the first part of this video presentation, I will concentrate on the so-called systems view. So what is a system? Here you have our definition. A system is a set of interrelated components that must work together to achieve some common purpose. As you can tell from this definition, a system is something that is complex. Complex meaning it has a lot of components. And the other side of complexity comes from the fact that not only there are a lot of components, but all of those components, they need to work together to accomplish some common purpose or common goal. We use the term system in our daily lives to describe those complicated arrangements of components that work together. And our lives are surrounded with different systems. For example, a car can be viewed as a system because, as you know, a car would have many components such as a steering wheel, wheels, windshield, engine, battery, and all those components, they work together to achieve the following common purpose: to transport somebody from point A to point B. In other words, the purpose of transportation or the goal of transportation. Then your body, human body, can be viewed also as a complex system because a human body consists of many organs, such as lung, heart, brain, and all those organs, they work together to achieve one common purpose, which is sustaining your living. So a system can be pretty much anything that has a lot of components that work together. But in the context of this class, of course, we talk about information systems, not just any type of systems. We're talking about specifically information systems. So what is an information system? It's a collection of IT, meaning hardware, software, networking, also various organizational procedures and processes, and also people, right, that work with those IT components and processes and organizational procedures, and all those components that are typically responsible for capturing, moving, managing, and distributing data or information. So this is what information systems are. In fact, just to give you like another synonym, the field of MIS, Management Information Systems, is often called IS, the field of information systems. And as you probably know, sometimes IT departments are also called IS, Information System Departments. Now, this definition is very important. And also I would say that knowing this definition is not just a matter of, some kind of conceptual rigor or armchair philosophy. I think this definition, and I hope you will see this yourself later on, has a very important practical implication. And the implication is that you need to understand that information technology, meaning hardware and software and networking components, is only a small aspect of an information system. It's only a small aspect of an information system. Using Venn diagram, we can draw something like this. If this is an information system, then IT is only a small aspect of that. Now, other aspects or other components of information systems include people, right? People that interact with the system, that are impacted by the system, that authorize creation of a particular information system, and then processes, because any information system implements or automates or streamlines a number of organizational processes. It also impacts organizational processes, because now when you have a new system implemented, you have to do everything with the help of that system. And then you also have data. Okay, so an information system is something that is simply much broader than information technology. Now, thinking of just to repeat it once again, it's much broader because it also includes people that interact with the system using different interfaces. It also includes different processes that are implemented or automated with the help of that system, and also data component. Now, viewing information systems solely in terms of information technology, meaning hardware and software, is not only wrong from that conceptual standpoint, it's also very dangerous. I see it over and over again. I see it myself with my own eyes. I also see it by reading reports about various IT projects. Sometimes technical specialists, let's say programmers, they're overly concerned and they're overly focused on the technology, on the IT aspect of information system. In other words, they focus on making sure that the hardware components and the software applications, they work together, and they work together effectively, efficiently, and that they don't crash and all those things, but they absolutely ignore other components of an information system. Let's say the people part. Now, the trick is, or the truth is that no matter how sophisticated, how perfect your IT is, it's of no use to an organization unless people know how to use IT and they are also motivated to use this IT. For example, in my previous organization, a few years ago, we decided to, the university decided to implement Blackboard. Now, Blackboard is a learning management system similar to Canvas. So they decided to implement Blackboard across all programs and all colleges and all courses. So everybody basically was mandated to use Blackboard. All faculty were supposed to use Blackboard in their classes. Now, the technology itself, the IT component, was never a big deal. In fact, the company Blackboard Incorporated, they just created like that institutional account for us, and everybody could access it, and all the courses were implemented in Blackboard. Now, of course, it took some time to customize the system, to populate it with certain data about courses and instructors and students, but it really took a few months. I mean, within a few months, it was all customized and polished. What took a long time, though, is the people and process part, and then also it touches on the data part. First of all, some instructors were simply opposed to this whole idea of using Blackboard. I think they kind of tapped into this more kind of fundamental fear of online education. A lot of faculty felt that this new technology will somehow make them inadequate or irrelevant, because not everybody has skills in information technology. Not everybody can, easily upload, download files, or do some kind of HTML edits to a layout of a Blackboard course. So they were worried about that. And of course, they wouldn't say that directly, but their justification mainly came from that philosophical, pedagogical side. They would say, well, look, my courses are not about, sending files back and forth online. My courses is about face-to-face interaction, team collaboration, and so forth. And there are a lot of people still who are not persuaded. I mean, they use Blackboard because they are mandated to use it, because the university's top management told them to use it, but they really kind of use it in a way that makes a joke out of the entire system. For example, I've noticed that some faculty, what they do with Blackboard, they just upload their files in the beginning of the semester. It's like all PowerPoints, all syllabus, all handouts are simply uploaded to Blackboard, and then they kind of teach manually face-to-face without even using Blackboard. And the only thing they use Blackboard for is they will tell students, well, if you want to download this particular presentation, go to Blackboard, you'll download it there. So people, some people after several years, they're still not persuaded. And then processes, because now since you teach in Blackboard, the question becomes, what about some organizational processes? Let's say grading. Should it be done in Blackboard because all of our grades are entered in another system, PeopleSoft? Should we integrate the data, the grading data, grades data from Blackboard with the data that is stored in PeopleSoft, so it's all automated? At some point they did, so whatever you enter in Blackboard would be automatically entered in PeopleSoft by running a script. After that, they abandoned this idea, and I think this was related not really to technology. It was related to the fact that faculty, they kind of use Blackboard for reporting, and they didn't want students to see those grades. It was something related to some kind of procedure, not really to technology. So if the person in charge of Blackboard, from the very beginning focused on IT, I mean, the project would fail miserably. Because IT itself was never problematic for our Blackboard project. It was all those other aspects, such as managing data, who owns data, how to access data, managing processes, which processes will be automated with Blackboard, which processes will not be automated, and also persuading people, getting their buy-in, making sure top management fully supports this project, and which is more important, is willing to give out rewards and punishment for those who use or refuse to use Blackboard. Those were the most important aspects of this project, not the IT itself. As I told you several times already, IT was never a problem. I mean, the system was working fine from day one. So this is why this definition is fundamental to the field of information technology and information systems and computer information systems, because it explains that if you are to make a particular IT project successful, if you are to make a particular software application work, then you cannot ignore all the components that are non-IT components. You cannot ignore the people side, you cannot ignore the data side, or the organizational process side. So that's why this definition is so essential to the field of information systems and computer information systems. To continue on that, again, we know that the word system is used widely in our daily lives. For example, let's say you come to your office, and you see that there's a lot of trash in the conference room. In ours, the conference room is not very clean. So you may say, well, we need to do something about our janitors. They don't clean conference room over the weekend. And your friend may say, well, don't blame them. It's not the cleaning department's problem. It's not their fault. It's the system's fault, right? It's the system's fault. What he mean by that? He can mean that what you're seeing, when you are trying to kind of blame the janitor colleagues for this problem, you're seeing only the tip of the iceberg. I mean, those people, they are part of the overall organizational system, and let's say that system doesn't allocate appropriate funds to some of the essential functions of the organization, such as cleaning, right? So that's what he means by that. It's the system's fault. He means that that it's the problem of the entire system, not of one particular component of that system. So that's what systems thinking is about. Again, a very fundamental philosophical framework or theoretical framework that defines the field of MIS. Systems thinking means seeing things as a whole. I mean, seeing something as a system as opposed to concentrating on individual components of that system. Again, over and over again, I see this problem not only in the context of the technology sector, but in all kinds of contexts. For example, a lot of time people would say, well, my boss is dumb. He doesn't know what he is doing. He told me to do this, and it's clear that it's not good for my job. All those things. Now, the real problem here is that the person who blames his boss for being short-sighted or dumb, he doesn't understand the entire system. I mean, it could be that indeed this particular decision compromises his or her own well-being. However, it's good for the entire organization, right? So, because we tend to have like narrow perspective. In ours, we only see our work, our needs. We fail to ignore that overall system that we are part of. And again, this is not something that is a sign of some kind of intellectual deficiency or short-sightedness. It's just the way it works. I mean, if you go to some of the fundamental books on economics, let's say The Wealth of the Nations by Adam Smith, this book was published like somewhere in the 18th century and laid the foundation for the field of economics and the field of business, I would say. I mean, this idea of specialization was explained in this book using a pin factory example. So, Adam Smith, he wrote that instead of having several people in one factory making pins on their own, you need to divide labor. So one person will be cutting wire, the other person will be sharpening it, the third person will be bending it, and then the fourth person will be packaging those pins. The productivity will go up. So this is like specialization of labor, right? But again, if you're specializing in something, by definition, you are ignoring other aspects of the organization. You're only focusing, you're only specializing in what is relevant for you, for your job, right? So that's what it is. But maybe you can afford that. You can afford to focus only on your job when you're a kind of low-level employee. You're on the bottom of the organizational hierarchy. But whenever you step into some kind of supervisory or managerial role, I mean, that's when it becomes very important to have a systems thinking, meaning viewing things as a whole, as opposed to concentrating on individual components. The other aspect of systems thinking is that not only you see a system as a whole, you also focus on interrelationship among those parts rather than parts themselves. And that helps you, and also in a way systems thinking helps you to deal with complexity, because systems thinking does not mean you need to kind of pay attention to everything, but it does tell you that any kind of system, no matter how complicated it is, can be broken down into some fundamental components. So systems perspective is useful for understanding the relationship among business units and the entire organization. And I would say even more specific than that, it's very helpful for understanding the relationship between technology, the business unit where this technology is implemented, and the entire organization. Because once again, if you narrowly focus on the IT component only and you ignore the people, the organizational side, then most likely your project will fail. And this is something that is empirically confirmed over and over again in all kinds of studies. Just another illustration of that systems principle, like a house, where you live, can be viewed as a system that has many components, like stairs, windows, doors, roofs, roof components, walls, and all those things. They work together to kind of support your living or provide a shelter for you, right? Now, as you probably know, in most places around the globe, you cannot really do modifications to your house unless you receive some kind of permit from the city, from the municipality. For example, it's not okay to dig some kind of trench, or let's say remove a wall inside your house. Now, the reason you cannot do that because you may not have a good understanding of the entire system, meaning you remove a wall because, let's say, you want to turn 2 rooms into 1 big room, right? But what you don't understand that this wall is an important component of the overall system. Let's say it carries some of the weight from the second floor, right? From the top of the house. And if you remove the wall, then other walls will get like an increased pressure from the roof, from the second floor. And because of that, your walls will start cracking, and the structural integrity of the entire house will be compromised. So, and I even saw like people who seem to be upset about this. They're saying, "Well, this is my house. Why do I need to get this permit from the city or from some architecture department? It's my house. I know what it is. I want to do all those modifications." But again, you may not. You may not have a good understanding of the entire system of your house. How like all those components work together. So that's why you need to receive a permit. So if you want to do something like that, if you want to install a bathtub on the top of the roof, you need to seek permit for that, because they will look at your house and say, well, look, if you install a bathtub on the roof, then there will be increased pressure on the walls and the entire house will collapse. And some people don't believe that. They do it and they find themselves in that unpleasant situation where their house walls crack and they cannot sell the house and they don't know how to fix it. They cannot fix it sometimes. And if you can, it's very expensive. And actually, I saw a person like in that kind of situation who did modifications to his house. Then the wall cracked, and then because there was like there were like underground waters, it started basically destroying the entire house. So that's why you need to understand your house as a system, as a collection of components that work together, that impact each other, and not just like as individual components. So what are some of the key elements of an information system? Well, first of all, you have a boundary, something that defines the scope or the size of your system. Then you have something called environment, something that seems to be outside of the scope of your system, but nevertheless has an impact on how the system operates and how the system is built. Then you have inputs, typically information that is coming into your system. Then you have outputs, information that is coming out of your system as a result of being processed by components. And then components are some functionalities, some things that the system can do. Then you have interfaces. Interfaces means like points where users can work with the system, or other systems can communicate with other systems. And then you have storage component, meaning where data is stored. So those are the most important elements of an information system, and we'll talk about each of those components in a bit more detail in a second. Boundary. Now, boundary is important because it delineates, it defines, it clearly communicates which elements are a part of the system and which are outside. Now, from the perspective of project management, this is one of the most important factors for ensuring success of an information system project. The boundaries of your project need to be very clear, and preferably, the boundaries should set a scope for your project that is manageable. Okay. Otherwise, it will be very difficult to control, to manage the entire project. And if you're not clear about what your boundaries is, then people, stakeholders, users, management will give you additional requirements. So the boundaries will change. Typically, everybody wants to increase the size of the project. They want to kill all birds with one single investment, one single information system project. So and you cannot afford that. If somebody keeps expanding the boundary of your system, keeps adding additional features, saying, why don't you include this? Why don't you include additional department? Why don't you include additional features? Then the entire system will fail. So it's very important to understand the boundary, what the system is and what it's not, from a management standpoint largely. Well, actually, it's also related to technology standpoint, because if you keep adding additional features and including additional users, then even from a technological standpoint, your system will become overly complex and will eventually fail, because you will not have the resources, meaning time and money, to support that kind of complicated functionality. So boundaries are very important. Then you have something called environment, everything outside of the system. Those things, in a way, they have no relevance to your system, meaning they're not a part of it, but in a way, sometimes they can have very great impact on your system, the way it's built, the way it's operated, and so forth. Now, if you remember that case about ERP implementation at Natural Springs, the problem there, most of their problems, they came from the environment, the kind of environment where the system was installed. Like, one of those things in the environment was the fact that they didn't have reliable IT infrastructure, so they had to find a number of technical workarounds. For example, they couldn't establish a reliable real-time connection between their headquarters in St. Petersburg and also their manufacturing facility in Krivogda, a small town around 100 miles from St. Petersburg. So those environmental factors impacted the system, the way it was built. And eventually, one of the environmental factors, which is that political battle that the CFO had with the CEO and chief marketing officer over the position of the CEO, eventually that environmental factor led to the failure of the entire project, although it had nothing to do with the system itself. So again, maybe as a coder, as a programmer, you may have the luxury of ignoring the environment, but if, as somebody who is a supervisor or a project manager, you cannot afford to ignore the environment within which a system is being implemented. Okay, inputs and outputs. Again, inputs are resources from the environment that are consumed by the system or manipulated within the system. In the context of information system, it's typically data. And then outputs is typically information. I don't want to get too philosophical about it, but there is that general distinction between data and information, where information is defined as process data. So basically, what happens is that you get data as an input for your information system, and then you get information as an output. And then you have different system components, meaning specific functional elements, in other words, the work that the system can perform or the processes that the system is implementing. Then you have interfaces, meaning specific points, specific places where two components of the system can communicate. And again, those components, they don't have to be IT components. It can be like a human interface, a particular screen which is used by a user to enter data or receive data from the system. And then you have storage. This is where the system will store data. But again, if you take like that broader perspective on systems, then storage can be any kind of holding area. So here we have some examples. I'm not going to talk about sales tracking, but let's say you have a payroll system. So for inputs, you have time cards, some kind of vouchers that employees use to, let's say, to communicate their attendance of office. Outputs are paychecks that are calculated based on time spent at work. W-2 forms that are calculated based on wages. Now, the kind of components that are implemented in the system could be calculating total pay for one employee, subtracting deductions, Interfaces can allow, let's say, a payroll manager to match time cards to employees to see which employee is getting, to see like individual time accounts for each employee and calculate checks based on that. Then also sort paychecks by department to see like which department has the most, the largest payroll. And then you can have like some kind of storage place, meaning a database where information about employee benefits and pay rates will be stored. So those are examples of system components of a payroll system. Now, one idea is that I'll skip this sales, sales system. Although you can look at it, you can pause and look at some of the components of the sales system. But components are basically functional points, the things or high-level processes that a system can do. Now, one thing about those components or processes within the system, there's something called hierarchical decomposition, a concept very useful when it comes to managing complexity. It basically says, the principle says that the process or any kind of component can be broken down into subcomponents. So basically, what you can do, you can view your system as one single component. Let's say this will be your payroll system, and then this component can be subdivided into smaller components. Now, this approach helps you deal with complexity. I mean, you don't have to deal with everything, right? So you start with a high-level idea, then you break this high-level idea or into subcomponents. So let's say you start with the idea that your system will implement or automate the payroll function, and then you'll subdivide it into, let's say, timekeeping, issuing checks, calculating benefits, updating tax forms, right? So once you break it down into those smaller components, you can break down each component into even smaller components, and then you can assign those little subcomponents to individual developers of people. So this is something that helps you deal with complexity. And also manage project, because if you have something big in front of you, you don't really know where to start, how to organize it, how to put it on a timeline, what needs to be done first, what needs to be done second. But through hierarchical decomposition, things become more manageable. Again, this kind of reminds me of another fundamental idea. This is how artists work, right? So if you observe how artists work, even when they produce like realistic, meaning photo-like pictures, they don't start just by drawing like every little aspect of a human portrait, right? So what they do instead, they start like with a sketch. They're saying, well, this will be like my portrait, right, with a human with arms. And then they say, well, let's add some details. So here we're going to have collar, right, and the tie. And here we'll have hair and ears, right? So they never start with details. They start with a sketch, and then they just basically improve, each individual component until they have photo-like precision, right? So the same principle is used here. You start with this overall system idea, and then you break it down into concepts. Interfaces. Again, interfaces are those points where different components of a system interact with each other, or meaning with other components of the system. Interfaces can be useful for filtering information, coding and decoding a message, let's say from human words to machine language that can be understood by the computer, by the software. They can also aid in error detection and correction. They can also serve as a buffer, like you enter something to a form before you update the system. They can also be like a security feature, meaning you can only access your system through a particular interface, so you cannot just go and start manipulating data records within a database. You need to enter password, and based on your password, based on your kind of level within the organization, you'll have access only to certain interfaces. And also it can help summarize, like it can just take a database and summarize something for a user in the form of a table or a graph or some kind of dashboard, which is a collection of elements. So interfaces are very important. In fact, I would say they're crucial because interfaces are the links between system components and people. And if you think about it, ultimately, any kind of information system, at the end of the day, it's built for people, right? It's built for people to use. So if people somehow cannot use it, let's say the interfaces are not there, or they're just too complicated, too cumbersome, then it's a big problem. Then people will not use it, and the entire system becomes a waste. In fact, if you think about the history of Apple computers, arguably their success came from the fact that from day one they were focused on interfaces. They wanted to make sure that humans can easily understand and interact with the electronic devices, with computers that they're producing. And I think they have been quite successful in that. And usually I don't believe those kind of marketing slogans, but I do believe that Apple has superior interfaces. And this is something that makes their devices very appealing to humans. This is just like another way to kind of conceptualize or explain systems view. You need to understand that information technology is related to other components like people, business processes, and the entire organizational structure, because the organization itself is a complicated system, with information technology being a small part of that system. So this diamond explains this idea. Because if you implement information technology, it will have impact on people. People will also impact information technology because they will tell you, as a developer, as a system analyst, what they want the information technology to be like or to do. Then processes will be impacted because information technology will automate certain processes. Also, current organizational business processes will dictate how a particular information technology artifact is developed, meaning what kind of applications are developed, what kind of features are developed. And then sometimes information technology will impact the entire organizational structure. There's a famous case on that by somebody named Walsham and Sahai. Basically, they were talking about a geographical information system implemented in one of the states in India. And the idea was that, I may not remember like all the details, but roughly speaking, there was this government service in India, and this government service was basically in charge of approving certain agricultural activities. For example, if you want to plant corn in a particular field, on a particular property or farm, you need to receive permit. Now, the reason permit was required not to make things more complicated, but because India, unfortunately, or certain parts of India, are subjected to constant floods, earthquakes, drafts and all those things. So that's why they said, well, we want to protect farmers from those hazards. So if you want to plant something, ask us and we'll tell you like whether it's a good idea or not. Because if, for example, if this particular area of the country is subject to frequent floods, then maybe you should think about growing rice versus corn, right? So they wanted to do that, and they implemented the system that basically automated everything. Before the system was implemented, there was this hierarchy of decision making where there was like a field employee going to the field, making observations, then coming back, reporting his or her findings to the supervisor. Then supervisor will draft some kind of preliminary report, then this report will go to top management, and then top management will sign off, on approval. Now with the new system, all those levels of managerial decision making were bypassed. The decisions could be made in just basically very quickly on the spot by the field employee. So they go to the field, they enter all the information, and they get a decision on the spot. Now, in a way, the system was a big improvement because it automated a lot of the processes. It made life of people easier. However, it violated one important aspect of the organizational structure, meaning it violated this authority, decision-making hierarchy. Now all the power was given into the hands of field employees. They were the only ones who had power to kind of influence the system. Supervisors, mid-managers, and top management now were crossed out, excluded from the process. Of course, they didn't like it because now they feel irrelevant. They feel like their job was replaced by the system. So that's something that is very important to understand how information technology impacts organizational structure. I recently published an article on this specific idea with one of my doctoral students. If you go to Google Scholar, you can search for my name, last name, Krotov, and then you can search for like Krotov, implementing GIS public sector, and you'll probably find that article. It's better if you go to Google Scholar. It's published in 2015. Kind of the same idea. A student of mine, he was a GIS manager for the municipality of Abu Dhabi. More specifically, he was responsible for issuing permits for sewage and water. So, for example, if you want to build a house, you need to connect to the sewage lines in the city, and you need to connect to water. So they would give you like those permits saying, well, this is how you connect, or this is, or they will prohibit certain construction projects because they will say, well, you will damage our sewage line. Something that I experienced myself by smelling it, because whenever somebody violates this rule and they start digging something or building a foundation for a house, so they damage the sewage lines, and you could smell it in the radius of 5 miles sometimes. And that's when my student would always disappear. Whenever there's some kind of sewage accident, he would disappear for a few days because he had to rapidly take care of this problem. So basically, the same idea. Before the system was implemented, there were like all those huge bundles of papers. There were all those people who were involved. after the system was implemented, some people were excluded, and of course they were not happy, and they didn't phrase their opposition in a direct way. They would always try to find flaws in the system, saying, oh, this feature is not implemented, this doesn't work, or this data can get lost, all those things. But the essence was that organizational structure had to change because of the GIS, Geographical Information System, that they implemented. Now everything had to be done through GIS, not through those manual processes, and some people felt excluded because their level was kind of compromised, meaning it was not powerful anymore, or removed altogether. So it's very important to understand that any information technology project impacts people, processes, and organizational structure. So yeah, that's what I was trying to explain in this slide. Okay, friends, so this concludes part 1 of our video presentation on Chapter 8. In my opinion, this is a very important part. So thank you for listening. And that we'll discuss other ideas that are kind of related to systems view, but a bit far from it in other parts. So thank you for listening once again.